Welcome to VoIP Frequently Asked Questions, our 30th monthly webinar covering technical, business, and partner topics to help service providers and enterprises build better voice networks. Building VoIP-based systems with SIP can be daunting. The entire telecommunications industry is a layered stack of technologies, some from the age of telephones with hand cranks, others from the internet age of packet switching and VPNs. Over the years, the experts at TelcoBridges have built a knowledge base about underlying telecommunications and VoIP technology, SIP signaling, network products, and design methods. In this event, we pull some of our favorite frequently asked questions from our video library, our forum, wiki, and your emails, sharing answers and insight that both beginners and advanced designers will find helpful. So let's get started. I'm Alan Percy. I'm the Chief Marketing Officer for TelcoBridges, and I'm glad to have you here join us today, along with Luke Morissette. He's our Director of Customer Support. And Luke, I appreciate you spending both your time and sharing your expertise with us here today.
Thanks, Alan, and a good day to all.
Yes, wonderful. All right, just a quick peek at the agenda. We're going to start with some introductions, which we've covered, and then we're going to talk a little bit about some of the resources that we've been using over the years to help educate folks, our TB forum and the wiki. Then we'll dig into our favorite FAQ. We've got quite a collection of questions that either we've pulled off the forum or wiki or from your emails this last week. And I do appreciate you sending those in. And some of them were actually frequently asked questions. So it'll be kind of fun to go through those. Lastly, then we'll cover where to learn some more. We've got some library of other materials that we'll share, and then we'll get into your questions at the end. So we'll promise to save some time for questions. So just a quick moment about the wiki, and Luke, I'll ask you to jump in here. So I know this is a culmination of materials across products and technologies, but maybe you could just give a quick overview of what people can find in the wiki.
Yeah, so you have all the traditional voice over IP products that we have, which is called like T-Media, T-Trans, and T-Sig. You have all the instructions, a data sheet, how to install them, how to upgrade them, how to configure these devices. And then on the one at the top is the SBC, which what we're talking about today. You have links for free or ProSBC and the same thing, how to install it, how to upgrade the system. And then if you look just a bit on the right, you have solutions, which is really interesting, SBC use cases. Every time we work with customers, we add new use cases that can help other customers install their systems.
Yep. And the one other area too is, the support functions, right? The various areas of support, some of the, more intricate pieces of configuration, et cetera. I know you cover nicely there.
Correct.
And of course, we've got the URL for the wiki here, and probably the best way to find it is just go to docs.telcobridges.com, and then you'll find your way into the wiki. And this is again, it's constantly online. We maintain it on a weekly or monthly basis. It's the most current stuff, so definitely would recommend you grabbing a short link to that, a hot link. All right, another area that's pretty dynamic is the FreeSBC, ProSBC forums, and this is a product that Luke, your team maintains. You just want to quick go over what they would expect to find in here?
Yeah, so in there you have, some of these frequently asked questions that we see here, but sometimes it's, more technical. It can go pretty deep in those forums. We have links to the training videos. Basically, you can ask any questions in there, and we'll get on it and help you to answer your questions.
Yep. And one of the things I love about the forum when I was looking through it is a lot of the questions that people might automatically have are been posed in there, and either Sardar or myself or actually some of our customers have jumped in and answered some of the questions. So this is a great resource also. So I wanted to make sure everyone knew this was out there. All right, so let's move on and jump into our frequently asked questions. And one of the first ones, I know for some this is like the basics, but we get asked this once in a while, which is transcoding, and then we'll get into a little bit more detail on how it actually works. So Luke, you maybe just want to give a quick overview.
Correct. So transcoding is a conversion of the media. So you take the RTP media stream that you receive on one side, and you will convert to another vocoder on another RTP stream. You know, a lot of installations we see are all using G711 everywhere. But you know, some of these carriers, they need to have a very specific vocoder, or they don't accept G711. So then you can use our transcoding devices to convert that.
Yep. And I think architecturally, conceptually, the idea is that the session border controller leverages a media server. And in our case, the media server, you know, we call it the transcoding unit, but it really functions as a media server. It's a standalone media resource device that the SBC can lean on to forward traffic for conversion. In the TelcoBridges case, it's a DSP-based media server, which has some benefits, right? It's a higher density, it's lower power consumption, and it's you know, a high density device. So I think that's a key thing.
Yeah, Alan, and also if we talk about the ProSBC, it's fully integrated in the ProSBC installation. So you have, once it's installed in the system, you have nothing else to do. It's going to find automatically a corresponding vocoder, and it's going to be transcoded automatically.
Great. All right, next question. What is a session? And this this question pops up quite a bit because we sell some of the software based on sessions, and so there's a question of exactly what is a session? Is a session a phone call? Is it half of a phone call? Is it just the incoming part or the outgoing part? So maybe you explain what this is. And there's a couple steps here.
Yeah, so there's more than one answer on this. One is it's a call coming in the SBC going out to another device. So this call between two users going through the SBC is one session. Okay.
Right.
Then if you need to have transcoding, which we talked about right now, it is still only one session. Okay. So you can have one leg of the caller with the specific vocoder, and the other leg with another vocoder going through the media server. This is still one session.
Right. And we should say that the session is not one of the questions that pops up, I think, sometimes is, oh, okay, so that's a session. So if that call drops and somebody makes another call, is that a second session? And of course, I think the answer is no. It's still using the same path. So that's the same session as the initial one, even though it's complicated, right?
No, but it's
So,
if the call is dropped, the session is free to be used
correct.
by another call, right? So
Right.
it's actually pretty easy.
Yep. Good. And so there's the media server that's integrated. That's still just one session.
Exactly.
Okay. All right. So the second part.
So then sometimes what we see is that you have registered users connecting to the SBC, and this goes to either a PBX or a soft switch, and the soft switch will make the routing decision and maybe make another call out through the SBC. Okay, so in this case, since it goes twice through the SBC, it will be counted as two sessions.
Right. And that obviously scales up to however many sessions that's been licensed in the particular SBC.
Correct.
Got it. Okay. All right. So one of the questions that was submitted was explaining some of the differences between SIP over UDP, TCP or TLS, and I think we got a couple of questions on this looking through the archives. Essentially kind of asking, why do providers choose one or the other? Why don't they encrypt at all? Why do they encrypt it at all? And I think, we distilled it down to a couple of things, right? And the first is that SIP over UDP is the lightest weight and easiest, and was the first and most widely used for operators. And why is it okay for an operator to use SIP over UDP inside their network? What's the issue there, or what's the non-issue there?
Well, it depends. Your network is, if it's a private network, or if it's a control network, or inside a VPN or something like that, then it's okay to run SIP over UDP, right? It's protected by the network that you are using. Okay.
Right. And it's lighter weight, right? The SIP over UDP is less complex for the endpoint systems because they don't have to decrypt the headers.
Well, it's less complex, but I think it's implemented everywhere, right? So it's the default standard for this. That's what really drives the SIP over UDP.
Okay. And then I think Microsoft probably led off the charge to use TCP, right? The SIP messages started getting larger, and then you end up with packets that are too large to fit a UDP header. So then they started using TCP.
Yep, correct. So you can use TCP for that, but SIP over UDP also supports fragmentation. So so let's say the reason to use TCP is not very high, right? So you can do it over UDP or TCP to reassemble the fragmented packets.
And it's not very common either, right? To SIP over TCP.
Yeah, I would say maybe 5% of the installations use TCP.
Yeah. Right. And then lastly, TLS.
Yeah, so then if you're running on a public network, one of the way to protect your information when you make calls is to use SIP TLS. You need to exchange keys before you start doing SIP TLS traffic. So it does require, let's say, work beforehand. And then the other side needs to accept it and maybe update the key every now and then. Some of the providers force you to use SIP TLS.
Right, right. Okay.
Just one more thing, Alan, is that even if the SIP is different protocols, the RTP is always on UDP traffic. Okay, so sometimes we confuse if SIP is on TCP, RTP is also on TCP. That's not correct, right? So SIP can be on TCP, SIP can be on TLS, but the RTP traffic, the media, will always be on UDP.
Correct. Yep. Good. All right. Hopefully we'll clarify that. So a question pops up once in a while. So why not just use VPN for all your remote offices, right? So there are applications where we run into IPPBX deployments, or small service providers who are looking for either now work at home or branch office solutions, and they've come to us and say, why can't I just use VPN from all the remote offices? What are the hurdles with this?
Yeah, so VPN is an excellent solution, right? If you can set up a VPN between your offices, this is the best, because you will encrypt all the data, not only the phone traffic, the media, but also the data traffic, and you in a secured environment between your offices. Now, the drawback of the VPN is that you need to set up a private connection between everywhere you want to send traffic. So in some cases it's possible. Other cases, well, it's very difficult to do that.
And we had that case study with Matt and his Austin Consultants webinar that we did a few months ago, where he talks about, he started out with a VPN for some of the school districts, right, that he was offering service to. And it just, after a certain point, it just become so difficult to manage all the different VPN endpoints that's when he came to us to talk about using a session border controller instead. Yep. Okay, so next is, we just talked about the solution to that, missed that. Okay, so how does SRTP secure the media? So, and then how can an SBC convert from SRTP to RTP? And you want to maybe explain this?
Yeah, so SRTP, what we do is we take the RTP information and we encrypt it, right? Just like in SIP, so you encrypt the data. So if you sniff on the network, you won't see anything. The difference here with RTP is that the encryption is negotiated in the SIP messages. Okay, so you have no specific configuration except saying you want SRTP on this network, and the SIP negotiation will decide on which keys to use, which cipher method, and it will be automatically implemented there. So, of course, if you can sniff the SIP traffic, then you can know the SRTP. So that's why usually when you use SIP TLS, you use SRTP together with SIP TLS.
Yeah, they kind of go hand in glove, right? If you're going to use
Correct.
SRTP, you have to use TLS because you have to encrypt the key exchange.
Correct, because if you can sniff the SIP traffic, you can know the key that is used for the RTP, and then you can decrypt it very easily.
Right.
Okay.
Right.
Well, you can convert from RTP to SRTP by just taking the RTP traffic and encrypting it on the other networks. Here we show a private network can use RTP because it's a secured environment, and the public network would use SRTP and SIP TLS.
Mm-hmm. So why not just use SIP over TLS SRTP for everything? What are some of the downsides using SIP over TLS and SRTP?
Well, the TLS, yeah, you need to exchange your keys with the remote side. So if you know you will be connecting to another service provider or another endpoint, and you can change the keys, yeah, you should do it. But if you don't know that endpoint or you can't exchange keys, then you will need to use SIP, UDP, or TCP.
And SIP over TLS with SRTP, it's difficult to diagnose or capture, right? I mean, I know from listening to some of your training sessions, I mean, it puts some particularly unique hurdles in front of capturing the packets and diagnosing problems, right?
If you don't have the keys, then you won't be able to decrypt the traffic there. If you use the ProSBC and you capture on the SBC, then you'll be able to analyze the traffic going through the SBC.
Okay. Good. All right. So how about resolving SIP interoperability issues? How does this work? And I think we put together a diagram here to help explain this. So maybe we can explain what a back-to-back user agent is and what all these UAS, UACs are.
Yeah, so, well, the session border controller includes many things. One is the server side and a client side, and you can receive, well, UAS server side and UAC client side. You can receive calls on one side and send them on the other leg. And once you receive the SIP calls, you can then adapt the traffic you're receiving so that the other side receives valid information. So it's possible to, for example, remove SIP headers that are being received. You can manipulate them. You can remove some of them. You can adapt, like we saw before, from SIP UDP to SIP TLS. So you can convert the protocol, convert the media from RTP to SRTP. Then you have early media settings that can be changed as well. So there's a way, if you use a ProSBC, there's a way to replace the ringback tones that are being played in the media stream. Mm-hmm. You can adapt SIP-I or SIP-T, okay, if you're using that. So there's a lot of things you can adapt there in the SBC.
And I think that the key piece is that the session border controller, because it has the back-to-back user agent in it, that user agent server on the left and the user agent client on the right, have these unique settings, right? So you can change the settings between them. So it, when a session goes through it, you decompose it, you pass the parameters across. You can modify them as you pass them across, and then as you reconstruct a message over on the client side, the message can have a different form, and therefore
Correct.
That's how you make those changes.
Yep.
Good. All right. So one of our popular questions, as a matter of fact, I think one of you submitted this like early this morning. What causes one-way audio, and how do we diagnose and fix the problem? And we had a little diagram here.
So if you look on any forums about voice over IP, you'll see that one-way audio is something that is very frequent, I would say. Okay, so with our experience of helping customers trying to troubleshoot issues, There's various things that can happen, but we took like 4 of them that happens more often. Okay, so there are sometimes when you make calls, you go through a router or a firewall or IAD, and the RTP streams. Okay, so when you open the initially you open the SIP traffic. Okay, that's pretty easy because it's a single port, single IP, and you just pass that from one side to the other. It's quite easy to configure in a firewall. However, the RTP stream can come on a set of different UDP ports. Right? And then you need to make sure that these UDP ports will be carried over from one side to the other without being modified. Okay? So you need to configure the phones, the firewall, and the SBC so that the RTP UDP ports are being carried over. There is NATing that is done sometimes. So then if you are using NATing in a firewall environment, you need to make sure that the SBC is aware that you are using NATing so that it can convert some of the SIP parameters for the remote side to understand where this traffic will go. Other things we have seen, maybe a bit less often, codec mismatch. So sometimes some devices will ask for a certain type of vocoder to be used, but it's not what it sends, right? So you need to adapt these things. So there's some bugs also that happen. Like my colleague was saying the other day, maybe you need to update the firmware of the firewall or of the phones to make sure you're at the latest version of these devices.
Okay. And just skipping back real quick. So, if the firewall decides to close the pinholes prematurely, then there's some techniques you can use to get it to stop doing that, right? And can you give me maybe a couple of suggestions on how to prevent that?
Correct. So either you configure the firewall to leave the connection open for a while, or you can refresh the connection. So you make sure that there is some traffic going through the firewall every now and then, so that the firewall says, okay, this connection is still active, I leave it open, and then the traffic can continue to go on there.
Okay. And that is something that if, for example, the firewall is outside the control of the service provider, he can manipulate on the SBC side.
Correct. We can do that.
Yep. Okay. All right. And then another pretty common question is, how do we measure voice quality? I know it's in some of the messages, it's in some of the logs and the reports that we get out of the session border controllers. So how is it measured? And then or if it's low, how can I fix it, or how can I improve it?
Correct. So for every single session that is open, and there is on this session when there is RTP traffic, we will monitor this traffic. Okay, so we use both RTP and RTCP traffic to give us some data about this RTP stream. For example, if we have lost packets, if we have latency, if we have jitter, and all of these parameters will affect the quality. So there's not only 3 parameters, right? There's many parameters that are analyzed, and there's also the type of vocoder used. Okay, so the type of vocoder will affect the quality of the media. And here we give some example of scores that are used in the MOS score. Okay, and then we compile all of this with a value, and this will give you the quality of your call. Okay, so the MOS score is maximum of 5, and we can store this information in the call detail records. So at the end of the call, you'll be able to get those information. But you can also see it. I don't know if some of you have used the call trace we have in the ProSBC. When you see in the call trace, you can also see the MOS score of the calls that went through the system.
Okay. So let's just get to the root of the problem, though. So what would cause lost packets? What in the network is likely the suspect that would lose packets or create latency or introduce jitter into the traffic?
Yeah, well, normally it's the network you're going through that will cause all those effects. For example, if you go on the public network, there's a good chance you will lose packets there because maybe some of these devices are overloaded and they will drop some of these packets. So you can detect that with by checking the sequence number of these RTP packets. Latency, well, the distance, of course, is adds to latency, but
Sure.
the number
Speed of
of
light.
switches, I'm sorry,
Yeah, speed of light. Yep.
speed of light, exactly. It's pretty fast, but the longer you go, the longer you will have the latency. But also through every time you switch, so every switch you go through will affect the latency, and
Mhm.
also if you switch from VoIP traffic to maybe if you're on a TDM network, you will add latency, right? Every time you switch
Right.
from one network to the other.
And then jitter is just the random delays that get introduced into the packets. And
For
if I remember correctly, one of the issues with jitter is that then the VoIP systems have to add additional buffering to wait for the packets because they're showing up at random times, and then that adds latency, which
exactly.
which then causes people to interrupt each other, right? Because your voice comes a half a second, a quarter of a second late, and it makes for a difficult conversation. We probably all had that experience on a cell phone.
Correct. And the ranges we've experienced is like if it's 300 millisecond, you need to be experienced user to manage this delay.
Mm-hmm.
And if you get to 500 millisecond, then it gets very difficult to manage the
Right.
conversation.
Right. Fortunately, we don't see that much anymore. Okay, so another solution where make sure there's no errors on the RTP streams, the networking issues, and of course the high quality vocoders improve the quality. Is there maybe just? I think when we were researching this, also too, there was some issues with the equipment that was in a network being out of the software needed to be upgraded or the equipment needed to be upgraded.
Yeah,
You run into
sure.
that once in a while too, right?
Sure, we see that, and the different issues that come in with different versions, and usually getting to the latest version will solve a lot of cases.
Right. Good. Okay. All right. So here, another one someone submitted, which is the difference between call routing and packet routing. I guess there's a little confusion. Obviously, they're both routing, but there's a big difference on those. So maybe you want to walk us through this.
Yeah. So call routing is a phone call that is received on SBC, and then we use the call routing table to route the SIP invites to different networks. So it could be either a soft switch, cloud network like Twilio or something like this. And once the call is established, then the call can go through the system. Okay. Alternatively, instead of using the internal call routing table, you can also use an external service like a radius server or a SIP redirect server. This will choose the routes, but it's only for calls, right? So
Mm-hmm.
SIP calls going through the system.
Right. Packet routing is very different, though.
And then you have packet routing. So this is defined initially on the system. You need to choose which networks, private networks, public networks that you will use in those systems. Maybe for different source of traffic, you will have different VLANs. Okay, so VLANs are level 2 traffic inside the Ethernet switches. And once it goes through, once a call goes through the SBC, then the call will be routed to the destination using the specific packet network.
Mm-hmm.
Right?
Mm-hmm.
So it could be different networks, could be different destinations.
So basically, the packet routing is almost like it's like the highway that's underneath the call routing. It's the transport mechanism, right? And then you can think of call
Correct.
routing as being the next layer up that instead now depends on that packet routing to be able to then do its call routing.
Correct. Correct.
Yep. Good. Okay. All right. DOS and DDoS attacks, kind of a common question. I think it comes up in a lot of when we get into some of our security webinars, this usually pops up in denial of service attacks and distributed denial of service attacks. They're basically floods of packets that enter into some kind of system to try to cripple it. And one of the tough parts with them is unfortunately, you have no control over the source. As a victim of one of these, it's like somebody just ringing your doorbell over and over and over again, and you have to deal with it. Separately, then there's the telephony denial of service attacks, which we can talk about those. And we got a couple of slides that explain all this. But protecting against DOS and DDoS attacks, you gave some materials here. You want to walk through this?
Correct. There's, I would say, three main things for DOS and DDoS, right? So first thing is to efficiently drop packets from bad or unknown sources, right? So once a source has been identified as not good, we need to drop the packets immediately, okay? So that it doesn't use any CPU or any processing from the system. And then the other thing is to also quickly identify the packets which are good and let them pass. So you drop the invalid, keep the valid ones. That's very efficient. And then the other thing is to monitor the traffic from the trusted sources so that there's no, traffic that is being, blasted through the system from a trusted source. So one of it happens sometimes if someone gets hacked, right? Like a PBX get hacked, it can start sending a lot of traffic through the system, and the SBC can, block this type of traffic if it detects unusual patterns.
Right. So a couple of things. First of all, within an SBC, there's, I know within the industry, there's a couple different architectures. One of them is that the session border controller has an embedded firewall, and that's the architecture that TelcoBridges uses, right?
Correct.
Yep. And the benefit of that is that the session border controller knows what ports and packets to keep, right? Because it knows based on the signaling which ones are good or should keep. And then it can tell the firewall to deflect the rest of them immediately, right?
Correct. So we monitor both the SIP traffic and the RTP traffic to make sure it's valid, right?
Right. Other vendors choose an architecture where it's a separate firewall and then they have to use an API to control these kinds of dynamics, right? They're deciding, which packets to discard, which packets to keep, using our APIs, and the side effect of that is it takes more time and there's more complexity involved in deflecting the traffic. In some other cases, there's no firewall at all, and they just depend on a statically configured firewall. And I think that there's obviously some huge disadvantage to that because they can't dynamically open and close ports based on the profile of the attack.
Correct.
So then there's the TDOS attack, and the TDOS attack, we talked about this. We had a whole webinar dedicated to this, but a TDOS attack basically is in a situation where a flood of telephone calls comes either to an organization or into a service provider. There might be robocalls, there might be a malicious attack on a business, there might be a dialer that's gone berserk, or a robocaller that's gone berserk. But the bottom line is you need to get rid of these calls and deflect them as quick as possible. So how is that handled?
Yeah, so then you need to validate the call. So the call will be accepted because it looks like a legitimate call, and then we can analyze the data that has been received. So the main data is the called number and the calling number that are present in those SIP calls, but there's also other parameters that can be verified from the incoming call. And we validate this, make sure it's good. We go through maybe lists of spam numbers and stuff like that, and then we can drop this call before it's being made through the system.
So of course the question comes is, where's this list? Would you put this list inside the SBC, or why would you? I know in the architecture here you show it's off in the cloud, but what's the benefit of having the list be in the cloud?
Well, the list in the cloud, it needs to be updated frequently, right? With any data that is being captured from all the systems that are on the net, to make sure that, you know, as soon as possible, if one number or data is being identified as spam, then we block it everywhere, not just at one place.
Right, right. And that's a key piece of this, right? The sort of centralized knowledge of if there's, you know, thousands of session border controllers that are in a service provider network handling calls, and they determine that somebody's started a robocall attack, they can then isolate very quickly what those numbers are that they're using, and they can spread the word to the rest of the session border controllers, you know, within a matter of seconds, telling them not to accept any calls for those numbers and to deflect them. Good. All right. So one of the questions that comes up that's product specific are, you know, what are the differences between FreeSBC and ProSBC? And I think this kind of pops up fairly often, and we try very hard to explain to people the differences. So I'm just going to quick pull up a page here, if you don't mind. Just give me one quick second here. I just want to show on our website. Let's see. Let me just change what screen I'm sharing. That's probably the best way to do it. So let me do this. Okay. I'm sorry, 1 second. It's going to take me 1 second here to find it. Okay, so I'm just going to quick show this screen here. Let me move this stuff out of the way here. All right, so here on our freesbc.com page, and you can see that now, right?
Correct.
Yes, okay. So we, in addition to the support resources we talked about earlier, the wiki, the FAQ, the forums, et cetera, are all here on the website. In addition to all that, we have a pricing page here, and this is this compare section sometimes people overlook. And this really does a real good job of explaining the difference between the two platforms. And one of the areas of confusion comes is not only just the feature differences, right? So, you know, FreeSBC has some basic feature set, and then a different support platform, or, you know, different options for support. You know, the simplified self-help and the wiki versus, you know, the additional effort that the training folks have. Obviously, big difference in pricing, right? Free versus $1 a session. But one of the questions that pops up all the time is, you know, what's the difference from a software standpoint? And I'm just going to quick shift back to our other screen here. So what's the difference? You know, do I have to do an upgrade? Do I have to do, you know, what's the process? If I download FreeSBC and I've been using it for a few weeks and getting comfortable with it, and I say, you know what, this is going to work for me, I would like to have a paid subscription for ProSBC. What do I have to do?
Well, the easiest way is probably just go on our store page, and then you buy the ProSBC, depending on, you know, how many sessions you want. And then once you order it, you will get, when you order it, you need to put the license key you want to upgrade. Okay, so either you put the license key that you had, the FreeSBC product key you had, or if you want a new one, you just put nothing in the store. Okay? So if you put the same key that you had before, it will be automatically updated for 1 year, and then you will receive a notification saying, go on your FreeSBC upgrade page and just renew the license right there, and it's going to be it's going to become a ProSBC for 1 year. So there's no reload of configuration. There's no reinstallation necessary for that.
And that's obviously the easiest way to upgrade from FreeSBC to ProSBC.
Sure.
And then the question then comes, all right, so the year goes by, the ProSBC, I forget to renew, even though I've, you know, received all these emails reminding me that I need to renew my subscription, and my ProSBC expires. What happens?
So what happens is at the end of that 1 year, it falls back to a FreeSBC. Right, so you may lose features like well, the ones you saw, you showed us before, Alan, the call trace and things like that. And then you have, I think it's 2 more months to renew to a Pro SBC. Okay, or else it's gonna remain a free SBC.
Yep. Good. Okay. Well, that's good. All right, so let's move on to talk about training. So there are a couple things. First of all, we definitely run into folks who are just getting started, maybe aren't real super familiar with SIP, and maybe they're looking for a little bit of help. And then also, once they've gotten past that hurdle, they're looking for some help on either ProSBC or maybe some of the media gateway platforms are looking for some training. So one resource I know we've worked with in the past is the SIP School. It's a great place to get the basics of SIP out of the way. I think you recommend this to people who come to you that are struggling with the basics of SIP.
Sure, and I followed those courses as well. So.
Yep. And it's an online training school. It's based over in the UK. Our friend he just does a great job with it. Graham does a great job with managing the SIP school. So. All right, so let's talk now to get past the basics of SIP and they're ready to start learning about ProSBC. And normally you would invite them to either come to Montreal or meet us maybe in Fort Lauderdale or someplace else for a wonderful training session that we've gotten some rave reviews. But this COVID pandemic put the kibosh on that. So maybe we can explain real quick this tech train program we've got set up for now.
Yep. So what we do is we plan some sessions which are online. So just like this now, we're on Zoom. We provide training. Well, it's usually like sort of 16 hours of training, and you can just join in. We will give the dates for the autumn session soon, and you'll be able to join those sessions.
Right, and those are about 4 hours a day over 4 days, and you do them at different time zones, right? So you've been doing them North America, Europe, and then also Indochina.
Correct. I need to get up early sometimes, but yeah.
At least it's just you, right?
It's just me, exactly.
But we recorded those and we published those recordings, and folks can use those to get trained too.
Yep.
And what we've done is we've put together basically it's kind of like my scouting merit badges. If you go to this TelcoBridges.com tech trained page and register, that lets us know that you're starting to taking the self-paced training, and you'll get links to all the materials, to the recordings, and also to a quiz. And when you complete the training, you feel like you're ready to take the quiz, you can go online and take it. It's like 13-question quiz. And the result of that, by passing that exam, will earn you your tech train status, and you get a nice certificate from TelcoBridges and some other branded goodies that we've been sending out to folks. So it's a great way to put a little extra education bling on your cube wall or wherever you're working when you get back to the office. So definitely would recommend that. Good. All right, so one last resource before we go to the Q&A window, and I see we've got a couple of questions here that pile up, is the talk about the video library. I mean, we've been working on this thing for now, 2.5 years? We've been building this video library. Mm-hmm. So we got all your training modules on there. We actually have 2 sets of them. We have the most recent set that you did, and then we also have videos from the live training that you did in Montreal last fall. So if someone likes to have the feeling of being in a classroom, they can do the classroom one. If they want to do the online, then they certainly have that set of modules. We also have all 30 of the recorded webinars, plus some others, so that some how-to tutorials that Luke, you and I put together over how to do installs, how to do certain configurations, how to do, for example, configurations of SIP trunking, AWS, other various installs. We got some customer interviews, obviously some of our frequently asked question sessions from the past, and some podcasts and much, much more. And obviously would appreciate, a subscribe if you'd like to, stay abreast on new content that gets posted there. If you subscribe, then you'd be notified when we put that out there. All right, so let's wrap up with, we got at least one question here started that Michael asks. I don't know if you've had a chance to peek at this, Luke.
Yep, I did look at it,
Great.
and
So I'm just going to, for the recording, let me just read it aloud here. So Mike asks, he's had some routing issues recently where the only solution was to set the privacy type to PAI on outbound naps to prevent 481 errors. So maybe you want to explain what this means first, and maybe if there's a potential solution.
yeah, well, we see those cases every day, right? You try to interface with a specific provider and you get into a specific problem, right? In this case, it was a 481. I was not aware of this case. Probably one of my team mates helped him fix the problem. But for 481, I saw is a transaction does not exist. Okay, so that means maybe the call was not established correctly or was dropped prematurely. Okay, and to fix it, he changed the privacy type on the PAI is the P asserted identity. That is the calling information that is in the SIP messages. Mm-hmm. I think the important thing to say here is you can do it, right? So you can modify the PAI, you can change the privacy type, you can remove these values if it doesn't work. But why did it happen exactly? It's difficult to say because it's the remote side that returned a 481. So either we talk with the remote provider and then they tell us, well, it's a 481 because this happened. Okay. Mm-hmm. But a lot of times it's difficult to reach this provider. So we can just analyze the data. So we can capture a lot of information from the network, like the SIP calls and maybe the RTP streams and other states of the system. And we analyze that. And then we can say, oh, maybe we could try this and it would fix the problem, right?
Right.
And it looks like the case was solved. But of course here, the other thing that Michael says is that, well, I'm having trouble finding documentation about it. It's quite possible it's not documented because this is maybe just a new case we have found, and it may not always be documented on the TB Wiki, depending on what type of error this is.
Yep. Well, another question has popped in via email late during the development process of this was about plug and play. Now we buy a USB device and we just plug it into our computer and everything just works, right? And the question is how come you buy an IP phone or you buy an IP PBX and you want to connect to a SIP trunking provider? Why isn't it plug and play? And why is it so complicated? And what do we have to do to get to that point where things are that simple?
Yeah, so I think we try to improve every time to make it as easy as possible. The best way we have found right now, since there's, the SBC is installed in many, many different environments. So the best way we have found right now is to do SBC use cases. And meaning that, let's say you have some remote phones and you have a provider and you want to interconnect them with a registrar, with the PBX, stuff like, and you need to find the right SBC use case, and then you follow the procedure. Some of these SBC use cases, we have uploadable configurations, right, which you can just change the IPs, because of course the IPs will change in each of these scenarios, and we can just upload it on the system with the new IPs, and maybe 95% of your setup will be done already. Okay, but we encounter new scenarios, new use cases almost weekly. So right now it's difficult to do a fully integrated installation without touching anything.
Sure. No, and I know some of the enterprise-focused SBCs, which is a very different role. That's it's a small SBC that would end up out at a customer's premise. Some of them have tried little pull downs, for example, say, hey, I'm using AT&T or I'm using broadband.com or something like that, to try to minimize the amount of configuration that's necessary. But the bottom line is you still need to know. You need to know your IP address. You probably need to know, there's probably some credentials that need to go in.
Correct.
Et cetera, et cetera. So unfortunately, it's sufficiently more complex than just USB type plug and play, that it takes still a little bit of work. And the best thing to do is probably to get smart on what all this stuff means and be able to quickly diagnose it. So,
And then ask for help from our team.
yep, yep. Good. All right. Well, Luke, that's it for the questions. I did want to kind of remind everybody that we've obviously we're publishing a recording of this, and if you find this, if you found this valuable, do forward this along to others in your network that would find it interesting and helpful. And we've got another topic that we're working on for next month, which is RESTful APIs, and we're hoping to have a customer come share a really neat story, and look forward to making that be part of next month's program. And Luke, one last time, I want to thank you for participating. You can punch your frequent flyer card for being on the webinar. This is like number 8, so very good.
Very good.
And I want to thank everyone for joining us today and wish you all a great day. So thanks again.
Thank you.